Okay. Okay, well, aren't we lucky to be able to start the school year with such a fantastic event? I'm really excited about it, and I think the kids will be too. And I'm so glad that JCPS is going to be in school, and the kids are going to be able to experience. So the total solar eclipse is August 21st, and if you want to go ahead and switch to the next one. So why is this such a big deal to everybody? And some facts about it. First of all, the path of totality is 70 miles wide, and it does cut from coast to coast. And that's what's so unique about this one. Everybody in the United States is within driving distance of being able to see the total solar eclipse, which we are not going to have the total eclipse in Louisville. We're very close. We're going to have about a 96% eclipse, which is a lot. However, you will have to always keep the glasses on, and we'll talk more about that in a few minutes. The United States is the only country for this eclipse that will be able to see the total eclipse. And it will, well, I already said it'll go from Oregon to South Carolina. The last time that we had a solar eclipse that was coast to coast like that was 1918. And the last total solar eclipse visible in the United States was 1979. So as you can tell, it is something that is unique. It doesn't just happen every day. Now there will be another one in 2024 that is a total solar eclipse, but it will not go coast to coast. It will go from the southern hemisphere up across Canada. And what it will do, it will cut close to Louisville though, so we will be able to see a good view of it, but that's still a long way away. Oh, and the eclipse that we're having then next Monday is the first one exclusively seen in United States history, in the U.S. First one exclusively seen in our country. Okay. Carbondale, Illinois, and Hopkinsville, Kentucky are two of the primary places to see it, the total eclipse. And the reason for this is the moon is just slightly closer as it orbits. And so the total eclipse will last a few seconds longer than anywhere else. It's not a huge amount of time. We're talking maybe, I think about 15 seconds longer than anywhere else. Okay, now what is the total eclipse? What causes it? It is when the sun is completely covered by the moon. Now, you think, how is that possible? The sun is obviously much larger than the moon. But what it is, it all involves the distance. The sun is actually 400 times larger than the moon, but the moon is 400 times closer to the earth than the sun. And to give your students an idea of this ratio and this immense distance in mind, I have a little demonstration here. The earth is actually about 25,000, I'm sorry, the moon is actually about 25,000 miles away from the earth. And the diameter of the earth is about it's 25,000 miles circumference. And so what you can do is give the students these dimensions, okay? So the earth is about 25,000 diameter. The moon is about 1/4 the diameter of the earth. And it is about, I'm sorry, I think I said earlier 25,000. It's about 250,000 miles away. So actually what you can do is take the diameter of the earth 10 times, and if you would mind taking that and the string, and get the students to figure out the math, and keep going. Okay. So for this ratio, for this size Earth and that size moon, that is about how far away the moon is from the Earth. Now, if you were to find the distance of the sun, it would be another 2¼ miles away at this size. If you reduce the sun down, another 2¼ miles away. So it gives the students a little perspective on the size and distance. You can see how much further the sun would be from the Earth. And actually, I have for all of you to take home, hopefully enough for everyone, maybe not. It's a little tiny version of this activity, and it gives the dimensions. It's about a 1-inch ball and then a 1/4 inch. And at this ratio, and it's got the string in there that was wrapped around the Earth, the little ball, 10 times. And at this dimension, this ratio, then the sun would be 300 yards away. So you could give the students this as a math opportunity to figure out the dimensions.
Yeah, that's what I was getting ready to ask, is what connection to what subject area, but it would be math. Mathematically, we're the only planetary system. Our moon and planet are the only one that can, we're it in the whole solar system that can see this. This is what you'd see if we were a Martian. If we were on Mars, they don't have that same ratio, so this is Phobos, the moon. They have 2 moons, Phobos and Deimos, and so Phobos never even comes close to eclipsing the sun. So we are like super, super, super unique in the fact that we have these nice ratios. We're the only one in the solar system that can do this.
And also, if you were to observe just in the sky, of course you're not supposed to look at the sun, but actually the sun and the moon appear to be the same size when you look at them. And this is a little demonstration you could give the students. They could work in pairs, and this could be the Earth, and this could be the moon, and you could have them stand distances away and see, you know, how far they have to be to block, for this little one to block the larger ball. And then I've got, and all these, by the way, I will give you a way to get some of these resources at the end of this presentation. But you could have a model of the sun and have them stand and see how far away they have to be to block that larger sun. And it just, again, gives them a feel for the distance. They could make predictions and then measure their actual results.
I mean, almost every single one of these activities we took from the Eclipse activity guide. They're really good. I mean, NASA scientists have done it. This will also be on the Twitter feed that she alluded to. So as teachers, we're always sharing and borrowing and stuff. So you can take it. I've made copies of these activities for we can do later after we're done with the presentation. I'm not sure that everybody's going to do everything, so I didn't make copies for everyone, but the whole thing is on the Twitter feed, so you can look through it.
Yes, and NASA, the website is a wealth of information, all free too. Okay, this should be a little video, if we could get, it should show the path of totality. Hopefully it will play. If not, there it goes. Okay, and you're seeing now where the path of totality is. It's this center line, that would be the shadow. The outer circles just show the partial eclipse. And we are in, like I said earlier, we would see about a 96% partial solar eclipse. But you can see it cuts all the way across our nation. So, and I've heard weather-wise, some of the best places are up in Oregon to watch it. Okay, the next slide, and that's a video as well. Now this gives you a little bit more visual image of what the shadow, what's causing the shadow. How it's the moon literally blocking the sunlight, and you'll be able to see the shadow, which they showed a solar eclipse on one of the NASA websites as seen from the International Space Station, and it was very cool because you could really see just the shadow. It was an amazing video.
And there's a free app that you can download called Totality. It's free. Totality, just do a search from it in your app library. Type in wherever you're going to be, and it'll give you all the times that we're going to experience here. So like, for instance, I'm on it right now. I type in Louisville, and I select Louisville, Kentucky, and it says the eclipse begins at 12:59. The partial, the maximum is at 2:27, and the partial eclipse ends at 3:51. So it's a nice free app.
Okay. And then this is a little demonstration that we have. We have these set up on that table. You'll be able to take them outside, and you can do this very simply for the kids. It's just a yardstick, a little 1-inch styrofoam ball on a little skewer, and then a little pony bead. glued to another skewer, and the kids could estimate, go out and figure out what the distance would be, and then figure out what angle also to hold it. They might be tempted to go out and hold it like this. Well, you're not going to see the shadow if you're going outside with the sun. You're not going to see the shadow up here, to be down there. So they have to figure out that they have to hold the yardstick like this to be able to see the shadow. And then if you put your hand, sometimes it's kind of hard to see it just doing this, but if you put your hand in front of it, you'll easily see the shadow. And then they can actually demonstrate what we just saw, what this video just showed. So that's a good demonstration. And again, they can use their math skills for this. I think this would be appropriate too for all ages. The younger kids, the teacher might need to demonstrate it. But I think they could see it and be interested in it. Okay, the timetable for the eclipse in Louisville, it will start at 12:59 in the afternoon. The maximum, and that just means that where the most sun will be blocked, will be at 2:27 p.m. and then it ends at 3:51. Total duration 2 hours and 53 minutes. So it is kind of a slow process. I'm not saying you need to have the kids out there for 2 hours. Don't think that would go over too well. But
adults would get bored with that.
Yes,
so.
yes. But, definitely maybe take them out at the beginning. If you can take them out during the maximum, that would be great. And maybe a little bit at the end, just so they can see the different times.
And your new art teacher, if you'll stand up, and introduce what your name is and show what you've made.
I'm Laura Roth, and this is just a simple activity where you can kind of show the corona, right? So you just take, they're going to do this in art if they come before the eclipse with me, and you just take a template of a circle and have smaller ones if they want to make, write more on it and stuff. You just trace around it, and then you just take your finger and smudge it. And then Ms. Brown, or Dr. Brown, suggested putting some pages in here that the kids can make observations on, drawings. No problem, thank you.
And she's going to do this for every class that she sees, but if you want to do it in the classes that she doesn't necessarily see by Monday, here is the activity. It's also found on the Twitter feed. But our suggestion is that they go out sometime either tomorrow, Thursday, or Friday with the glasses to see what the sun looks like normally. And it's not like a, aha, wow, I've got cool glasses moment. Like on Monday, if you give them the glasses for the first time, what do you think will happen?
They won't know how to use them.
They'll focus on the glasses. These are the coolest glasses ever. So you want to get that novelty effect out of the way, and have them kind of used to glasses, kind of like they'd be used to a pencil. That's my goal, at least. Have them go out and then maybe in their notebook draw what they see with their glasses on. And then that would be a pre-eclipse or a, quote, normal.
And then maybe they could make predictions of what they think they'll see, and then afterwards, what they actually saw.
Right.
And they could write about it too, draw pictures.
Because it's all about feelings too, because this eclipse will make you feel a little different, and so you want to capture all those elements in writing, not just about the science, but writing about, so how does it feel to be out here in the sun? Is your skin warm? And then the temperature will maybe change slightly, so that's something to also notice. And I just encourage you to go out sometime between tomorrow, Thursday, or Friday with the glasses, so that they're not like, wow, we're going outside and we got cool glasses, and that takes over.
Okay, if you could click on the. Yep. This is, and then first one. Just click on the. This is going to show you a little visual of what the eclipse will look like to us from beginning to end. Hopefully, and then this is what I want to show. If we can get it up there. But it's just a video demonstration of what we will actually see. It's important to note we are not in the path of totality, so we will not be able to see the corona, unfortunately. That's the big deal. That's why everybody wants to go to the path of totality, so they can see the corona. And you know, the flames, occasionally you can see the flames come off, which I'm sure would be wonderful. Unfortunately, we're not in the path of totality, but we will be able to see the moon cover most of the sun. However, because it's not total, we have to keep the glasses on at all times because the UV rays are still coming through. Even if a sliver of the sun is still available, still showing, which is how we'll see it, that means that the UV rays are still coming through, and it could damage your vision if you're not wearing the glasses when you look at the sun. So this will show, this is a sped up version of what we will see and how it will look like here in Louisville.
So right now, we can go outside and look at the sun and cause permanent sun damage. There's nothing going on Monday that isn't occurring out there right now. What happens when we go outside is our natural reflexes are like, oh gosh, we're gonna say, you know, you just physically can't. Our natural body reflexes. Well, this kind of takes over our natural reflexes, you know, when it gets shaded over, just like, hey, I can stare at it, it's not uncomfortable. However, as Donna said, there is no point at which you can look at the sun on Monday, look at the sun, and take your glasses off. There is no point in that. Never can you take your glasses off. Now, when you get your glasses today, you'll put them on, you'll see that they're very, very dark, so you won't be able to see the walk. So as you would normally walk outside in the sun today, you're going to have them walk out normally. Then they'll put their glasses on and then observe the sun. They should not be looking at the sun without their glasses on.
Because even that little sliver is still sending out enough of, again, it's the UV light that is what could damage, and it's still sending it out. Okay, we can go to the next.
And ideally, you would go out maybe at pre, and at mid, and at end, so that you see it at 1 o'clock, and then you see it at 2:20ish, and then you see it at the end. I know that may or may not be possible with all your classes, but that would be ideal. Not 3 hours out there, but space it out to have them draw at various times.
Okay, safety, the next one. Go ahead and go to the next.
Yeah, we can't hammer this.
Okay, we are emphasizing it, but it is very important. We do want to keep our students safe, and it is just very important. And I know the little guys are going to be tempted to take off those glasses, and we just have to be vigilant. And that's why Dr. Brown came up with a great idea for the little ones to put some elastic on.
Yeah, and this is only like from, I'm not going to say the vendor, but you know, it's $1 of elastic, and then I just punch 2 holes, and then you can either staple. But you all are crafty enough to be able to make these so that I made them for a little kid, but you can't take these off. They're almost like little goggles, so that you can have your student helpers. Also, 14 method students will be here. Some of you all are here right now to assist you with these activities on Monday. So you will have your normal teaching staff, your paraprofessionals, your aides, and you will also have method students and student teachers from U of L here. So they're here in part a lot to help you, but also to monitor safety. That's my main thing I'm going to underscore in classes. Like, they're going to make sure that they don't fall off accidentally or however they manage to get off. But I would encourage you to do this for the K through 2.
And I would recommend you take the kids out. They can have their glasses in their hands, and tell them ahead of time, do not look at the sun until you say it's okay. Have them sit down, because when you put these on, you really cannot see anything. I mean, it's black. The only thing you will be able to see, you'll know the general direction of the sun, so then you'll be able to look up and boom, you see the sun. It looks like a little yellow ball. And again, you all will get to test these out today. But I would recommend they sit down just to avoid them fall. I mean, when they're doing that, you never know. They might lose their balance and fall down. These are very important.
Any
And
questions about safety or any concerns right now? Questions about anything that we've gone over to date? I mean, right now?
okay. How can you incorporate this into lessons, cross-curricular? Well, first of all, science, it's very obvious. The phases of the moon, which that's a demonstration that we have in
The U of L room. For
Okay.
5th grade specifically, I know that connects to your content. In the spring, the 5th grade does the phases of moon. So I'll have it set up in there for 4th and 5th graders between 2 and 2:30, because most of the stuff is in here, but I need total darkness for that.
How can the little moon hide the giant sun? And that was this demonstration, with the size difference, and have the kids estimate how far away they need to be. They could even measure it, give them a yardstick and they can measure the distance. And then figure out, using the dimensions, the real dimensions of the Earth and the moon, and figure that out. Something else that's not up here, but that is, I just tried myself for my class, is get those UV sensitive beads, and you can still order them. There's still time from Amazon if you want. And they change color in the sunlight. Have the kids experiment, put the bead in water, and see if that will block the UV light. Have them cover it with a cloth, see if that will block it, and have them cover it with the glasses, and they'll see that it will block the glasses do block the UV light, and that maybe will bring home to them the fact that, oh well, these really do block the sunlight out. Viewer, yeah.
Yeah, so if you've got some students that maybe didn't turn their permission form in, I know JCPS is going to send home permission forms, and we're trying to collect them on Friday. We also have viewers that are don't involve glasses and that can be used set up outside, and she's made one, and you can make one yourself out of a cereal box.
It's very easy to
Cereal
do.
box, aluminum foil, and I brought in some materials if you wanted to make one today.
Yeah.
You could also use a colander. Just go out there with a colander, and you will see the effects of
The shadows,
The shadows with that many holes. You will see the moon eclipse that many times.
You could even go under a tree and see the
Yes.
leaves, the sun shining through the leaves. If you look down, you'll be able to see the eclipse
Or
and
your
the
hands.
shadows on the ground.
You can do your hands like
Yes, any way, hold a paper with a pencil hole
None
in
of
it.
this. None
and
of
you'll be able to see
looking
it.
directly
No.
in the sun. Every
Down.
single one of these are looking down. So if you're using this box and you're viewing here, where is the sun? Where do you think the sun's going to be if you're viewing here in this box? Where's the sun going to be? If I'm here, where's the sun on my head? Yes, it's up here.
Behind, yeah. You'd want to stand so the sun is behind you.
Yeah, and you're not.
And this area, there's another hole under this aluminum foil. The way you make it, and you could use a shoe box, cereal box, any box. There's a sheet of white paper inside that I taped inside the box here. This is the hole for viewing. There's another hole right here, and I poked, you probably can't see it, but there's a small hole that I poked in the aluminum foil. So you would, and that's a great way to present it to the students. Okay, where should the sun be when you're looking? Well, it should be behind you. You would hold the box like this, and the sun would shine in this little hole, and they will be able to see the pinpoint hole on that white paper inside the box. And they will be able to see the eclipse covering over that little dot of light.
Most schools that don't have the glasses, which you all do, most schools are going to be doing things like this, or setting up a tripod so that the sun is coming in through a pair of binoculars or through a telescope, and you can view it down there on the ground. Most schools are setting up things like that. So if you feel more comfortable with that, but you all do have the glasses.
Okay, Matt, again, how can the little moon hide the giant sun? Figuring out distances, percentages, the yardstick eclipse, again, they can figure out, they can estimate, and they can measure the distance, see which one works out best. If you want to know. For language arts, Moon Bear Shadow Activity. That's with a storybook called Moon Bear Shadow, and this is geared toward the younger children. Would you like to explain, or what you would do is you could make, and we have the supplies over there for you to make this little board with the tree and the bear, and you go through the story. You could read the story to the children, and they could play with the shadows, and can you make the shadow of the bear in front of it? Where would the light have to be?
Yeah, there are 5 copies of that book. I purchased 2. There are 3 that Carrie Ward has supplied from the library. So there are 5 copies that you would use with this book, and then have the students explore shadows. First grade does shadows in the spring, so this completely aligns with the curriculum that you would already have to teach. They just get a little bit of exposure to it earlier, doing long and skin and thin shadows and thicker shadows.
Yeah, and we already talked about they could journal. That's another way to incorporate language arts. Journaling before, give them vocabulary words they could create sentences with, and look up the definitions. Okay, social studies. There are a lot of myths and legends about what Native Americans and people of all cultures used to think was happening to our sun. And for example, the Vikings thought wolves were chasing the moon. In Vietnam, the myth was that a frog was eating the moon. And something interesting, Christopher Columbus used the solar eclipse to his advantage to persuade Jamaicans to give his crew food. Apparently the Jamaican people did not want to give any food. They were somewhat hostile, and he said, well, I'll darken the sky. He knew, which is amazing to me that they knew back then, that he was so perceptive of the stars that he knew a solar eclipse was coming, but he did, and he said, I'll darken the sky. And when he did, they gave him everything he
It may
wanted.
have been a lunar eclipse, but there's a lot of folklore. There's quite a bit of folklore, and the cultural things, like you may need to find out from your students. There are cultural aspects of this eclipse. Cultures from India don't eat anything during the entire eclipse. They won't, because they think that the sun is not, the UV light is not getting in, which is true, and that bacteria could exist. And so that's a cultural thing. So I wouldn't try to persuade anybody to do anything that their culture says that they're not allowed to eat or drink for 3 hours. So you may want to ask some students.
Apparently, too, I was just reading, the solar eclipse happened during when there was battle going on at one point in history, and the two sides they saw the eclipse. They said, we're going to stop. And so it ended a battle. Art, we already talked about the journal cover. The kids could, make draw pictures and interpret the eclipse however they want. Okay, interesting things to tell the students to look for during the eclipse. The temperature change. There will be a slight drop in the temperature. Street lights might come on. The crickets might start chirping. Bats might come out and start flying around. So changes in animal behavior. Changes in light levels. And this is something I found.
There's an app for a light meter too, if you want to figure out how to do a light meter. It's free.
That's
it's
great.
It's complicated, but I did test it out, and it works pretty well. A lot of photographers use it, so photographers are used to using. But there's a free light app.
Okay,
right
so that's
now, I
bringing
think
in technology.
Yeah.
Yeah, and if you like to do it the old-fashioned way,
This is hard.
this is almost like a reading chart. It'd be great to take the kids out maybe tomorrow, Thursday, or Friday, have them look at this, measure how far away they can read, the most legible line, and then during the eclipse have them do it again. And we have a couple of copies of this if anybody wants it, but it's just sentences, and it tells you the point font, and then they could write that down. That's, getting data, collecting data about what they can see for the light levels. Okay, I have created just a Twitter feed. It's hashtag Cochran Solar Eclipse, all lowercase, all one word. If it has the resources that we presented for all of this stuff on there. I don't know. I didn't put it on there. Did you put it on there? I'll try to put the PowerPoint on. Yeah. Yes, I'll try to put the PowerPoint on.
I have the PDF of it, so I can.
Okay, if
email
you
it
want
to
to
you.
just, yeah, that'd be great. But go to that. If anybody has any comments, questions, if you're looking for information, just type that in, and all this stuff will come up.
Now the fun part. We're actually going to have you all go outside, because we ordered the sun today and it appeared. I've ordered it for Monday, right? I think it was a 10% chance, and so everybody's just really watching the weather. So these are in packs of 30, and what I'd like for you to do is your class roster. You know how many other instructors are in your classroom, so take one pair for your students and one pair for you. I also I'm hoping I'll have leftovers. I've accounted for that, for all cafeteria staff, all counselors, treasurer, librarians. So I've got everyone covered here in Cochran classes, but I want to make sure that the students and the teachers have them first, because I didn't really know the full enrollment. So if you are a K teacher, I'm going to hand you out, and then so just return those to Katie, please. These are in packs of 30, so if you think you'll have like 25, then you'll remove 5 and give them to Katie. They are ISO approved. The ISO number is on here. They're not from Amazon. They have been ordered a long time ago. They are not older than 3 years, and they have not been scratched. Those are the 3 things that NASA wants for your glasses to be approved. Now, if you give them to the kids, like on Wednesday, Thursday, Friday, and they get scratched, you know, that's why you need to be very careful with the lenses. They can scratch the cardboard, but not the lenses. So
But
there's that other safety thing.
It is important that you try these out just so you can see, because you really can't see anything. When you put them on, it's black.
Oh, yeah.
And it's when you are outside, you put them on, and then you find the sun, and the sun, it just looks like a little orange ball. Also, if you all wouldn't mind, we have, you can do the yardstick eclipse outside. You can test that out. There's more of these yardsticks over on the table in the back. You can take the box and go out, and if you'd like to see how to use it, you can make some of your own boxes. You can take the colander out and try and see what the shadow looks like. Of course, you will definitely see the eclipse even through the colander shadows. So feel free to try all these activities, and if you have any questions, of course, Dr. Brown and I will be here to help. Well, first of all, they need to realize that when they put them on, they're not going to be able to see to walk. So they should be in a stationary position before they put them on. And then they put them on before they look up at the sun. But once you get them on, then just look up and you'll be able to see it. It's a little yellow or orange dot is what it looks like. And that's about it. They just have to make sure they keep them covering their eyes the whole time, because, again, we are not in the path of totality, so UV rays will be coming down.
I think this is like the coolest thing ever.
Okay, that's pretty cool. I like that. That's awesome.
No, it's on this part.
Wow. Oh my goodness.
So you gotta hold it down a little bit. Now you should be able to.
Yeah, the fan has to be completely behind you.